Hello friends, once again we begin with the syllabus of electronics, in which we already have the topic of filters in the previous lecture. Now we begin with the same sub parts of filters or the types of filters. So in the previous lecture we learned the two types of filters, that is the capacitor filter and inductor filter. Okay, now we have the third type of filter in the power supply circuit. So there is a special role of the filter circuit in case of the power supply after the rectifier circuit. Okay, now check carefully the presentation. Okay, check carefully. We have the third type of filter, that is called the LC filter. Now before that we have separate inductor and separate capacitor filters. So that will be useful for making smooth DC output voltage from the fluctuating DC output of rectifier. Okay. Now check carefully the circuit diagram. So the diagram consists of the AC input, and this input is from, suppose, the transformer. Then the transformer input is given to the rectifier circuit. Now we know the different types of rectifier that already we have learned: half wave rectifier, then full wave rectifier, then bridge rectifier. So these will be the rectifier block here. Now we have the important part of filter circuit, that is inductor L and the capacitor C. So these two will be called the LC filter. So this inductor L, which is in a form of coil and having the core, the two lines represent the core here. So this is inductor which is connected in series with the load resistance, and capacitor is connected parallel to the load resistance here. And output voltage appear across the load resistance, that is a smooth DC voltage. Okay, now check carefully the working here. What we have to write down in examination, or simply the working of circuit, is check number first point. LC filter is also called L section filter. So it is the symbol letter L. So L, because we have, this will be L shape, the two sides, C capacitor side and inductor side. So because of that we have the L section, L shape section filter, or we have another name, choke input filter. Okay. Now the choke L, so choke is used for inductor having the certain core material. So choke L is connected in series with the output of the rectifier, and capacitor C is connected across the load. So that already we have explained in diagram how the connection of L and C in the circuit here. Now number third point, when these filter is connected between the rectifier and the load, the choke of inductance L. Now check carefully, so we have the important part, the choke of inductance L and a small DC resistance offer a high reactance to AC component and small resistance to the DC component. So what is the role of the choke inductance or choke of inductance L in this circuit is, so that third point is very important. Teacher always check the, in the answer you should have the point number third in the answer of the question. So when this filter is connected between the rectifier and load, the choke of inductance L, so choke of inductance L and a small DC resistance. So choke is made from the coil, and the coil has two terminal, and across the two terminal we have certain resistance. So that is called small DC resistance. Okay, and it has inductance L. Offer that inductor or choke has offer high resistance or reactance. So high reactance means resistance to the AC. So AC will be blocked by that particular choke or inductor. Inductor offer the high reactance to AC component. So its AC will be blocked by that inductor, and small resistance to the DC component, means DC will flow through that inductor So there is a negligible resistance for the DC. So DC pass through that inductor, AC blocked by the inductor. So that is the role of inductor in the LC filter. Now we have the role of capacitor. Check carefully. The capacitor C offer low resistance to the AC component. Now check carefully. The capacitor is connected parallel. So low reactance to the flow of AC. So AC will flow through that capacitor. Check carefully the diagram also. Okay. So capacitor bypass the AC component. So AC doesn't flow toward the load, but it will bypass or pass through the capacitor and go to the circuit here. Doesn't flow towards the load resistance. So AC will be bypassed through the capacitor and DC doesn't flow through the capacitor. So that is the working of capacitor in the circuit here. So capacitor C offer low reactance to the AC component and very high resistance to the DC. So DC has experiences the high resistance. So DC will be remain across the capacitor and that will be appear across the load resistance. So that is the role of capacitor in this circuit. Okay. Now we have certain the advantages, disadvantages, and one more point, the ripple factor is independent of load resistance. So we have independent ripple factor, but it is increased with the increase in L and C. So ripple factor independent of load, one point, and second point, it increases with the increase in L and C. So as value of L and C increases, the ripple factor also increases like this. Okay. Now we have the advantages. Now check carefully. We have 4 advantages and 3 disadvantages. So what we have the advantages of the LC filter. So in this type, the current flow continuously without which increase the efficiency of transformer. So current flow continuously. We require continuous current in case of DC supply and which increase the efficiency of transformer. So transformer efficiency increases as it will flow as it has the constant current flow. Okay. Now number next is it gives better voltage regulation than the capacitor input filter here. So it will be give better regulation compared to the capacitor input or single capacitor input filter here. Because of the 2 component will be act as a filter here. Okay. Now number next third ripple factor is independent of load, that already we have written the same point. So ripple factor independent of load resistance. So that also one advantage. The inductor may be replaced by a resistor for light loads. So inductor we can replace for light loads. Suppose we have the load resistance was negligible or small load resistance, and in that case we have the provision to replace the inductor with resistor here. Okay, so this is the advantage of the circuit. Now we have some disadvantage also. So there may be a separate question. Write the advantage and disadvantage of the LC filter here. So we have the disadvantages. Number first, large size of inductor. So inductor should have large size. So size has one drawback here. Now number second is because of large size it cost more. So the cost of inductor is more here compared to capacitor. Number third, external field is produced by the inductor here. So this disadvantage is only because of the inductor component. So inductor should have large size, and because of large size it has the particular cost also. So cost is more. And number third is the field will be produced when current flow through the inductor. Inductor means one type of coil, and the coil will produces the magnetic field. So the external field is produced by the inductor here. Okay, so these are the points here we consider in case of hello. So in case of the inductor filter. Okay, now check carefully. Next part. Now the 4th type of filter that we have to study is okay. Now number 4th part, check carefully. The RC filter. So we replace here inductor by resistor, and that is called the R and C. Now we have the RC, we can have the multiple RC components, or we connect the multiple resistance and capacitor connections. Okay, check carefully the diagram. We have again the AC input, then full wave rectifier, then we have parallel capacitor, then here we have the block in which we connect the R and C, R in series, capacitor in parallel, again RC like this. So this will load resistance. Section 1, one combination of RC, section 2, second combination of RC across the load resistance, and here we obtain the smooth DC voltage VO. Okay, so this is a simple diagram. Now what is the working of this diagram is, so here is the role of the resistance is same as inductance, or resistors play the same role similar to the inductor here. Okay, so check carefully. Number first point, this type is also called capacitor input RC filter. So capacitor input RC filter, we have the name of this circuit here. As we connect the capacitor parallel, and that is called capacitor input RC filter. Now typically R is at least 10 times greater than XC. So what is XC here? This is called capacitive reactance. So resistance R in comparison with XC, it is 10 times greater here. So the XC means, what is the role of XC is the capacitive reactance, and that capacitive reactance is used when we have the role of AC circuits or AC current. So AC, we have opposition, flow of AC voltage or AC current, that AC will be opposed by the quantity, and that quantity is called reactance. And for C, that is capacitive reactance. Capacitor has certain reactance. Reactance means opposition. So that is XC here, and compared to XC, we have R is 10 times greater. Okay. So in previous circuit, we have suppose XC. So this will be connected in parallel, and compared to that, we have R will be 10 times greater here. So we have the comparison here. So this will be one factor. Now number next is third. Therefore, ripple is dropped across resistors, series resistors, instead of across RL. So each and every each and every section has resistance, and AC will be block across R, again block across R. So the majority of AC component or ripples that will block across these resistors. So no AC will be flow towards the RL here. So AC will block by these two resistors. Okay. Along with the role of capacitor also. So each section reduce the ripple. Check carefully. Each section reduce the ripple by factor of at least 10. So as it is the 10 times greater than XC, so factor of ripple will be reduces by 10. Therefore, AC components are removed by this filter here. Okay, with the help of the resistor. Suitable only for light loads, small load current, or large load resistance. So if you have the light load means small resistance or small load resistance. If load resistance is small, then current will be large. So small load current, and large load resistance. So this will be applicable for this condition. Okay. Now check carefully the disadvantages here. Poor voltage regulation, and this is because of what happens in case of the resistor. So resistor also block the DC also. Along with the AC will be blocked by resistor, but along with AC, there is some DC also blocked here. So there is a regulation is not perfect, or we can say there is a poor voltage regulation. So as resistance also block or oppose the DC, so certain DC voltage will be blocked by the resistor, and we can say that there is a poor voltage regulation. Now number next is loss of DC voltage across each R. So there is also the voltage will be lost across each resistance. So certain potential is required to overcome that resistance. So that is a loss will be always there in case of the RC filter here. Require adequate ventilation to conduct away the heat produced in the resistor. So as current flow through the resistor, that it will be get heated according to heating effect of electric current, and as it is heated, there may be a chances the heat should be sent to the environment. So it require the ventilation here, require adequate ventilation here. Okay, so this we require the certain provision to lose the heat easily to the environment and to maintain the temperature here. So require adequate ventilation to conduct away the heat produced in the resistor here. Okay, so these are the disadvantage of RC filter here. Okay, now we have finished the topic of filter circuits. So in which we today we learn the two types of filters. That is the number third is LC filter and number fourth is RC filter. And in previous lecture we learned the capacitor filter and inductor filter. So there are four types of the filter circuits in our syllabus. Now we have the next part, that is concept of regulation. So there is an important topic and we have number of points in this topic. We have what do you mean by regulation here and what are the different circuits used for regulation. So we already know what do you mean by regulator here. Regulator means there is a either increase or decrease in voltage. When there is an increase in AC mains voltage, suppose AC mains voltage is 230, and if there is a certain short circuit and the voltage will be 230 become 240, 260, 270. So the voltage will be increases. So as AC mains increases, the DC also goes on increasing. So power supply that is work on AC. So that also voltage will be increases. So that may affect the our device or the particular appliances we can say. So that we require regulation here. Regulator we require here. Okay. So number first point what we have given according to your textbook. So when an unregulated power supply is used, ripples are filtered from the rectifier output using filter. So in case of unregulated power supply, there is no regulator, that is called unregulated power supply, which consists of transformer, rectifier and filter suppose. And ripples are filtered from rectifier output using filters. So filters remove the ripples, but what happens? Check carefully. But the voltage across load resistor may changes because the supply does not have good voltage regulation. Okay, so voltage across load resistors may be increase or decrease, and that because of the two factors. Either we have one is called the line regulation because of line voltage, and second one is load regulation. So voltage across load resistor may change because the supply does not have good voltage regulation, and that regulation has two concepts. The output voltage reduces as the load current increases. Now check carefully this third number point. Output voltage suppose 5 volt, and that 5 volt is across load resistance. Suppose if we change the load resistance, either we increase or decrease, and accordingly current will flow through that load resistance. And if there is a current will flow, there is a potential will be changed. Or voltage 5 volt may be changed to suppose 4 volt, 3 volt, according to the load current. Suppose in case of load current increases, load resistance decreases, load current increases, and in that case output voltage reduces. So instead of 5 volt, we see that we have only 3 volts suppose remains because of load current increases. So this will be the one type of unregulation. Now the DC output voltage changes with, check carefully number 4 point, the DC output voltage changes with change in input AC voltage. Suppose input AC 230 and that 230 suddenly become 270. So input will increases, and we have suppose a regulator and having output voltage 5. So if 230 becomes suppose 270, then 5 becomes suppose 6, 7 like this. So that may damage our instrument here or electronic instrument or device. So this DC output voltage changes with a change in input AC voltage. Okay, so there are 3 and 4 points. Accordingly, we have change in the output DC voltage. So therefore, to maintain constant voltage across the load, even when there are variation in either AC supply voltage or load current or both, voltage regulation is necessary here. Okay, so we have one 2 marks question in case of examination. why there is a voltage regulation is necessary here. So we have these following points we have to write down in examination for 2 marks question. So why voltage regulation is necessary? So these 2 points are important. We have to discuss the number third point, fourth point, and to have that particular output voltage should remain constant, we require voltage regulation. Okay. Now before going to start with the regulator, we have certain definitions. So they are called the power supply characteristics. So what are the power supply characteristics? So we have number 4 to 5 characteristics. So this is number first here. It is called a load regulation. Okay, so load regulate. Load means resistance, and across the load resistance we have the voltage. That voltage should be regulated, and that is called the voltage or load regulation. Now check carefully what is the general definition. The load regulation is defined as change in regulated output voltage. There is a change in regulated output voltage when load current changes from minimum to maximum value. So when load current will be changes, if there is a change in load current, because there is a change, as there is a change in load resistance changes, load current also changes. So when there is a change in the load current from minimum to maximum, and according to this change, there is a change in output voltage, then this is called the load regulation. And that load regulation is expressed by simple formula LR, as a load regulation is equal to VNL. NL means no load minus VFL means full load. No load voltage minus full load voltage. So that will be understood with the help of example. Suppose we no load. So we have output 2 terminals across load resistance, and load voltage with no load means there is a no resistance. So we have no load resistance means we have low resistance. We remove the load resistance. Suppose we have no load resistance, the terminals are open, and for open terminal that is called no load, then we have that is called VNL. So VNL means no load voltage, and number next is full load voltage with the full load here. So FL means full load voltage here, and the difference is called the load regulation here. Okay, so this particular part we are going to understand once again in case of practicals also. So here is the theoretical part. In case of practicals, we have to once again have the formula, and we have the regulation concept using the, by changing the input voltage or changing the load current, we have the concept of regulator, and that in practical we have the concept of Zener diode as a voltage regulator. And one more thing, there is a LM317. So that practically we perform the experiment, we perform that particular part of load regulation. We calculate the load regulation with the values. Okay, but theoretically we have load regulation LR is equal to NL VNL minus VFL, and accordingly we have no load and full load. Okay. Now number second characteristic is the line regulation. Now check carefully. The line regulation is the change in regulated load voltage. Line regulation is a change in regulated load voltage for specific range of line voltage. Line voltage means AC mains voltage, and that will typically 230 volt plus or minus 10%. So 230 volt AC mains voltage plus or minus 10 voltage, and when there is a change in this line voltage, we have change in the regulated voltage. That is in terms of, you have to study in terms of line regulation. Okay, the line regulation changes from line voltage changes from support 207 volt to 253. So we have AC mains 230 volt. Suppose it decreases to 207, and it suppose increases 253. And if there is a change in the line voltage from 207 to 253 volt, if load voltage changes, now output DC voltage is called load voltage. That load voltage will be changes from suppose 8.8 to 9 volt. So there is a 0.2 voltage will be changed when there is a sudden change between AC mains voltage 207 to 253. There is output voltage changes by 0.2, 8.8 to 9 volt. Then line regulation, we can have the simple formula SR is equal to 9 minus 8.8, that is equal to 0.2 volt here. and we have the percentage line regulation formula. So SR divided by V normal into 100 here. So SR means what? So that already we have change in the load voltage for full line voltage. So change in load voltage. Suppose for example 9 minus 8.2. This is in change in voltage. So change in load voltage, that is suppose 0.2. That is the SR, and V norm means nominal load voltage. Nominal load voltage means average voltage here. Suppose 230 is average. That is called the nominal voltage. So V norm means nominal load voltage here. Okay. So for nominal load voltage means suppose we have 230, means 230, suppose we have average value, and for 230 how much is the load voltage? That is called V nominal voltage. So for nominal AC voltage we have nominal load voltage here. Okay. So these also we have to do in practicals also. So in that case we understood better with the help of certain calculations. Okay, so these are the formula in case of the line regulation. Now we have one more formula that is called output impedance. So that is also given directly in your syllabus. The output impedance of the regulated power supply E is very small at low frequencies. So output impedance means the opposition to the flow of AC by inductor, capacitor, resistor all together. So that is one type of resistance to the AC. So output impedance of the regulated power supply is very small at low frequencies, and we have the R out. Small r means the output impedance. R out, and CL stands for closed loop. That is equal to R out 1 plus A into beta. A is called gain and beta is called the feedback factor here. So this is the calculation for the output impedance here. That is, the formula is directly given in your textbook here. And according to this equation, use of voltage feedback reduces the output impedance here. Regulated power supplies have typical output impedance in milliohm. So milliohm is very small impedance here, and this is can be done using voltage feedback technique here. So here we have the gain of the amplifier, and here we have beta is called feedback factor. So that we have learned in concept of amplifiers in standard 11th. So we already learned the concept of transistor amplifier, and in that case we have gain of amplifier denoted by capital A, and beta is called the feedback factor. That is in case of oscillators using the transistor circuit. Okay, so this is the formula called for the output impedance. Okay, now we have the ripple rejection. So ripple means the component of AC, fluctuation of AC. The ripple indicate the change in input voltage. Suppose input voltage changes, and that is indicated by ripple. A voltage regulator reduces the ripple that come in with the input voltage. Okay, check carefully. Voltage regulator reduces the ripple that comes in with the input voltage. So regulator also has a role of reduce the ripple. Up till now we have only the ripple can be reduced by filter circuit, but here we have the voltage regulator also reduce the ripples that come in with the input voltage. Now ripple rejection RR is usually specified in decibel. So we have one more new quantity called decibel, that is a unit used in case of the intensity, and that intensity of sound we have the unit called decibel, and that same unit we can use in case of the ripple rejection also. For example, RR is suppose 40 dB. So 40 dB means the output ripple is 100 times smaller than input ripple. Output ripple is 100 times smaller than the input ripple, so that is called 40 dB. If it is 20 dB, then it is 10. 40 means 100. So like that we have the calculation in logarithmic scale. So that we have the calculation of decibel. Okay. So just check carefully, and decibel we have again recall in physics also. Calculation of decibel in case of intensity here. Okay. Now number last is suppose fifth, over voltage or overload protection. So we have the important part. Generally in our regular power supply this facility is not there. But for the latest power supplies, we have this facility that is called over voltage or overload protection. Now check carefully. In power supply, due to overloading, a large current flows which may damage it. So if suppose the large current flow through the load reduces, load decreases, load current increases, load resistance decreases, load current increases. And in that case, suppose we have large current flow, and because of that large current, the power supply may get damaged here. So for that also we require the protection. Now, overloading can occur due to short circuit or negligible load resistance. Suppose we have very small load resistance, or we short the power supply. Power supply is output to terminal, and if suppose by mistaken we short that supply, output terminal we short, then what happens? Large current flow, and due to large current, heat will be produced, and because of heating, the coil will be, or the particular circuit will be get melt, or the copper wire will be get melt here, or there is a damage of the circuit here. This is because of the large current flow, and that is called overloading here. That is happen because of short circuit or negligible load resistance. Now number third, in some power supply, protection is provided against temporary overload. So this will be facility. In some power supply, we have protection against temporary overload. So temporary overload, we can have the certain protection circuit here. Otherwise, due to overload, there may be a damage of the whole circuit. Either rectifier will get damaged or the filter will be get damaged because of the excess current. And number fourth is important. Current limiting technique is used for this purpose here. So current automatically limited. If we short the supply and suppose the limit of the circuit is over 5 ampere, 5 ampere current can flow through the load resistance. But if we short, then 10 ampere current will flow through the load resistance. And if 10 ampere current flow, the circuit will get damaged. But we have the facility, according to number 4th point, current will be limited with the help of that particular technique. So check carefully. Current limiting technique is used for this purpose here. So current limiting technique, or we have certain circuit that uses the phenomena of current limiting technique, is used for this purpose here. Okay. So we have the 4 to 5 points in case of the power supply characteristic, and in the next lecture we have the part of regulator circuits. Initially, we have the regulator using Zener diode. So Zener diode already we have learned in the 11th standard, and then we have the transistorized regulator, and then we have the current limiting facility, and then we have the 3-pin inbuilt circuit, inbuilt IC that's called the IC regulator, and which has two parts, fixed and variable. And then we have the concept of SMPS, that is called switch mode power supply. That power supply is generally used in case of the CPU of the computer. Okay. So in next lecture we begin with the Zener diode as a voltage regulator. Okay.